How did the United States military execute one of the most audacious rescue operations ever attempted behind enemy lines? The answer traces back to a fundamental principle that runs through every branch of the armed forces. No one gets left behind. That is not a slogan. It is a standing operational commitment. One that authorizes commanders to dispatch entire assault packages, burn tens of millions of dollars in aircraft, and put elite operators on the ground in the middle of a hostile nation, all to bring one person home. This mission began the moment an aircraft went down over Iranian territory. Both crew members ejected. The pilot made it out quickly. But the weapons systems officer was in serious trouble, wounded from the ejection, on the ground inside one of the most dangerous countries in the world, with IRGC militia forces already moving toward the crash site. His training kicked in immediately. He pushed upward, away from the wreckage, and climbed until he reached the top of a rugged mountain ridge, where he activated his distress beacon. The CIA was already running a counter-move, feeding false information into Iranian networks and pointing their search operations in entirely the wrong direction. By the time the IRGC realized the deception, it was almost too late for them. But not quite. They converged on the ridge in force. What followed was a direct confrontation between U.S. Special Operations Forces supported by A-10 Thunderbolts and MQ-9 Reaper drones, and an Iranian military that was furious, well-armed, and closing fast. And even after the WSO was secured and loaded onto an extraction helicopter, the operation was not over. 2 transport aircraft on the improvised forward airstrip broke down at the worst possible moment. Rather than let classified hardware fall into Iranian hands, U.S. commanders ordered them destroyed on the spot. This is how it all unfolded. This is Stage 1. At 02:15 hours, a 2-ship formation of F-15E Strike Eagles crosses the Iranian border at low altitude. The crews are flying a precision strike mission against a hardened underground command facility, the kind of deeply buried target that requires a GBU-28 penetrating munition to defeat. Their route takes them through the Zagros mountain range in Kermanshah province, threading between the jagged ridgelines using terrain-following radar to stay beneath the detection threshold of Iran's Bavar 373 long-range air defense network. Look at the map here. This is the valley corridor they are navigating. Narrow, dark, and almost completely invisible to ground-based radar systems because the mountains themselves are doing the masking. The problem is what happens at the moment of release. To deliver the GBU-28 on target, the lead jet has to climb above the terrain. There is no way around it. That pull-up maneuver exposes the aircraft to any short-range radar system that has line of sight. And in a gorge below the strike corridor, a highly mobile Tor surface-to-air missile battery has been waiting. The moment the F-15E breaks the ridge, the Tor achieves a lock. 2 missiles leave the launch rails in quick succession. The pilot reacts immediately. Flares deployed, high-G evasive brake executed. The first missile chases the decoys. The second detonates on proximity, its fragmentation warhead shredding the hydraulic system. With no hydraulics, the aircraft is uncontrollable. Both crew members eject over the mountains. The pilot lands in accessible terrain and is recovered within hours. The weapons systems officer comes down in a far more dangerous location, injured, alone, and already inside the IRGC's search perimeter. The Sandy protocol activates the moment the ejection is detected. But the WSO cannot simply sit and wait for rescue. His survival training dictates his next move. Get to high ground, establish sporadic communications, and stay ahead of the search teams working the valley below. Despite his wounds, he covers more than 2 miles of broken mountain terrain on foot and climbs to a ridgeline, sitting at 7,000 feet above sea level. He activates his emergency beacon, but only in brief, controlled bursts. A sustained transmission would give the IRGC signals intelligence teams enough data to triangulate his exact position. Short bursts are enough for U.S. forces to track him without giving his location away. The clock is running. This is Stage 2. While the WSO is holding his position on the ridge, CIA operations officers are already running a deception campaign inside Iran. The operation is straightforward in concept and extraordinarily difficult in execution. Seed credible false intelligence into Iranian military and intelligence networks, indicating that U.S. forces have already located the downed officer and are moving him out on the ground through a covert overland route toward the Iraqi border. The fabricated exfiltration route is specific enough to be believable. Iranian commanders take the bait. Ground forces, militia units, and signals intelligence assets begin repositioning toward the Phantom route, away from the actual ridgeline where the WSO is hiding. The deception buys the rescue package a critical window of reduced Iranian presence near the real objective. This is Stage 3. At 02 hours, the skies over southern Isfahan province and the Kilui district go from silent to lethal. U.S. military operators, Delta Force and Navy SEAL Team 6, the tip of the American Special Operations Spear, are inbound aboard MH-6 Little Bird helicopters. Small, fast, extraordinarily maneuverable rotorcraft designed specifically for operations in confined terrain. Each Little Bird is armed with miniguns and rocket pods, built to lay down covering fire in the tight mountain corridors that larger helicopters cannot navigate. Behind them, MH-60 Pavehawk helicopters carry additional assault and extraction personnel. High above the mountain floor, miles above the action, an entire electronic warfare architecture is coming online. EA-18G Growler aircraft begin jamming Iranian early warning radar frequencies across a wide regional footprint, throwing a storm of interference across the electromagnetic spectrum and effectively blinding ground-based radar operators at the exact moment the rescue package penetrates Iranian airspace. HC-130J Combat King aircraft serve as the airborne command and control nodes coordinating the entire package from altitude. And threading through all of it, an MQ-9 Reaper maintains continuous infrared surveillance on the WSO's position, feeding his real-time coordinates to the inbound helicopters. This is Stage 4, and this is the part that has no real precedent. 14 miles north of Shareza City in the southern Isfahan province, there is an abandoned agricultural airstrip. Look at it here. 200 feet wide, 3,900 feet long. By military aviation standards, that is barely enough space to operate. But it is usable, and usable is enough. U.S. forces touch down on that strip and immediately establish a defensive perimeter. In the middle of Iranian territory, 14 miles from an Iranian city, American Special Operations personnel have just stood up a functioning forward operating base. The purpose is simple: to have a staging point close enough to the objective ridgeline to support the extraction operationally. The audacity of it is difficult to overstate, but the logic is cold and clean. This is Stage 5. The insertion helicopters navigate the final kilometers to the ridge at nap of Earth altitude, staying below Iranian radar coverage by following the terrain contours. They reach the WSO's position and establish a 360-degree defensive perimeter. Operators covering every approach, Little Bird miniguns sweeping the slopes below. The WSO is alive. He is injured, but he is alive, and he is now inside a ring of steel that the U.S. military assembled across 2 countries and 2 nights to put around him. For a brief moment, the mission appears to be on track, but the horizon starts moving. IRGC ground forces, popular mobilization units, and armed local militia elements have identified the ridgeline. They are coming from multiple directions simultaneously. Look at this ridge. The U.S. position is surrounded on 3 sides, taking incoming fire from higher ground and from the gullies below. What followed was an absolute slugfest, a sustained hours-long gun battle fought in broad daylight at altitude in the mountains of southern Iran. U.S. operators held a full 360 perimeter under continuous pressure. Little Birds orbited above the position, their miniguns working the slopes. A-10. Thunderbolts arrived on station and began delivering close air support with the GAU-8 Avenger cannon, 30mm rounds at high rates of fire, hammering the IRGC columns advancing through the Quisa and Keken areas below. The sheer volume of air support from the A-10s, the Little Birds, and the Pavehawks degraded the Iranian advance, inflicted casualties, and kept the extraction corridor from collapsing. All of that firepower was buying the ground teams one thing: seconds. And second by second, under that umbrella of air cover, the Special Forces helicopters loaded the WSO onto the extraction bird. The hardest part, it seemed, was over. It was not. Back at the improvised airstrip near Shareza City, two HC-130J Combat King transport aircraft assigned to carry the remaining U.S. personnel out of Iran suffered critical mechanical failures simultaneously. Neither could take off. An IRGC vehicle convoy had identified the location and was closing at speed. There was no time for repair attempts. Commanders issued the order: destroy the aircraft in place. U.S. demolition charges reduced both HC-130Js, worth approximately $72 million each, to wreckage on an Iranian airfield. Classified avionics, communication systems, and mission data went with them. 3 additional aircraft were scrambled to evacuate all remaining U.S. military personnel before the convoy arrived. The timeline was razor-thin. It held. The wreckage of at least one MH-6 Little Bird was also found at the site, destroyed by the same scorched earth protocol. What the IRGC found when they reached the airstrip was charred metal. Nothing recoverable, nothing exploitable. But the operation was not complete. A second rescue action was running in parallel, targeting the A-10 pilot who had ejected over the southern mountains. At 02:45 hours, roughly 30 minutes after the F-15E shoot-down, A-10 Thunderbolts operating in the border region were diverted to provide rescue escort under the Sandy Protocol. One of those A-10s descended to low altitude to neutralize an IRGC quick reaction force advancing on the downed aircrew, executing a strafing run with its 30mm Avenger cannon. The run was effective, but the noise and the tracer fire gave away the A-10's position as it banked out of the attack. Iranian ground forces had been equipped with Chinese-manufactured infrared-guided shoulder-fired missiles, reverse-engineered derivatives of Russian man-pad technology widely distributed to IRGC-aligned forces in the region. One of those missiles found the A-10 as it climbed out of the strafing run, slow and exposed, and detonated against the right turbofan engine. The titanium armor protecting the cockpit absorbed the worst of the fragmentation. The pilot survived. But with one engine destroyed, the aircraft could not maintain operational flight indefinitely. The pilot made the correct call: point the aircraft away from the mountains toward the Persian Gulf and punch out over water near the Strait of Hormuz. The jet went down in the southern Gulf. The pilot was recovered. At 03:15 hours, a dedicated combat search and rescue package crossed the border. An HC-130J serving as airborne command and control, followed by 2 HH-60 Pave Hawks with the call signs Pedro 11 and Pedro 12. They pushed deep into the Zagros range as dawn approached, flying under the radar and topping off fuel in midair to extend their time on station. At 04:45 hours, Pedro 11 located the A-10 pilot's infrared strobe. Pedro 12 assumed an orbit above, providing overwatch with its .50 caliber door gun. Pedro 11 flared for landing. The para-rescue men on board hit the dirt to establish a perimeter. Then this happened. A concealed Zu-23 anti-aircraft gun, a Soviet-era twin-barrel system with no radar signature whatsoever, completely invisible to the electronic warfare architecture overhead, opened fire from a hidden position. It was a deliberate ambush. Heavy armor-piercing rounds tore through Pedro 12 as it orbited, severing transmission lines and wounding crew. The pilot forced the crippled helicopter into a hard-controlled landing near Pedro 11's position. Pedro 12 was down. The only aircraft that could still fly was Pedro 11. Under covering fire from the para-rescue men on the ground, the crew of Pedro 12 sprinted to the surviving helicopter. But the Zu-23 was still firing. At 05:20 hours, the HC-130J overhead coordinated a fire mission. 2 F-35 stealth fighters holding high orbit in electronic silence dropped precision munitions on the gun position. The Zu-23 went silent. Pedro 11 was now critically overloaded, carrying its own crew, the A-10 pilot, the para-rescue men from both aircraft, and the surviving crew of Pedro 12. The pilots applied maximum power. The rotors fought for lift in the thin mountain air. The helicopter barely cleared the tree line and dove back into the valleys below, trading altitude for airspeed, racing the fuel gauges to the Iraqi border. At 0530 hours, Pedro 11 crossed back into Iraqi airspace. Every person on board was alive. Now let's step back from the timeline and examine what made these aircraft so vulnerable, and what ultimately brought them down. To understand the F-15E shootdown, you need to understand the geometry of terrain masking. When flying at low altitude through mountain valleys, the aircraft's radar cross-section is effectively hidden. The terrain absorbs and scatters the radar energy before it can return to any ground-based receiver. Think of it as standing behind a wall. The Bavar 373 network is essentially blind to any aircraft below the ridgelines. That invisibility is the entire point of the terrain-following profile. But to release the GBU-28 accurately, the jet has to climb. That pull-up takes 8 to 12 seconds. In those seconds, the aircraft steps out from behind the wall. The Tor M1 system positioned in the gorge below had been waiting for exactly that moment. The Tor uses a phased array radar for target acquisition, with active radar homing on the terminal phase of its 9M300-31 missiles. Each missile is 2.9 meters long, weighs 167 kilograms, and travels at Mach 2.8. The fire control computer calculates an intercept solution in under 3 seconds. The ripple fire pattern, 2 missiles in quick succession, is designed specifically to defeat aircraft that successfully spoof the first shot with countermeasures. It worked. Now look at the A-10 vulnerability. The A-10 Thunderbolt II is built around survivability. Its cockpit is encased in a 540-kilogram titanium armor shell capable of withstanding 23mm rounds. But the aircraft's flight profile for close air support, low, slow, and loud, creates a different kind of vulnerability. The Chinese FN-6 Manpad variant used in this engagement does not use radar. It uses an infrared seeker head that homes on engine heat. Once inside, you will notice how compact that seeker head is, roughly the diameter of a grapefruit. But its sensitivity is sufficient to detect a turbofan exhaust plume at ranges up to 5 kilometers. The A-10's radar warning receivers have nothing to detect because the missile system emits no radar energy. By the time the pilot could react, the engagement was already in the terminal phase. The titanium armor saved his life. The aircraft was lost. The F-35, which participated in this operation in a support role, also sustained damage during one of its sorties, reportedly from an infrared-guided surface-to-air missile. This is the critical vulnerability of 5th-generation stealth in terrain-masked environments. The F-35's radar cross-section is optimized to defeat radio frequency radar. Its geometry and radar-absorbing coatings make it nearly invisible to systems like the S-300 or S-400. But its single Pratt & Whitney F-135 engine produces a significant infrared signature that passive sensor systems can detect without emitting any energy of their own. Iran's 358 loitering munition, a hybrid between a cruise missile and a kamikaze drone, flies subsonic search patterns and scans with optical and infrared sensors until it acquires a target. It does not show up on radar warning receivers. The F-35 is equipped with a distributed aperture system, 6 infrared cameras providing a full spherical view around the aircraft that detected the incoming threat and alerted the pilot. High-G evasive maneuvers and flares were deployed. The aircraft sustained shrapnel damage but executed a successful emergency landing. But the incident confirmed what air defense analysts have argued for years. Stealth defeats radar. It does not defeat heat. The Zagros Mountains neutralized billion-dollar radar networks on both sides. In that terrain, the most decisive factor was not technology. It was the institutional commitment to keep fighting at catastrophic material cost until every person came home. 2 HC-130Js destroyed on the ground. An F-15E and an A-10 lost to enemy fire, an MH-6 demolished by U.S. forces to prevent capture. Against all of that, every American who went into Iran on that operation came out alive. That is what Leave No Man Behind actually costs. Separately, The F-15E crew, the pilot and the weapons systems officer whose rescue this entire operation was built around, still required a dedicated joint special operations raid the following night to complete their full extraction. That operation is its own story, but the outcome was the same. No one stayed behind. We make original videos from scratch and animated by humans. So please subscribe to not miss a